Wave motions and Doppler's effect. A wave is a disturbance that propagates in a space, transports energy and momentum from one point to another without the transport of matter. Classifications of waves: medium necessity, mechanical wave, elastic, non-mechanical, electromagnetic wave. Vibrations of medium particles: transverse wave, longitudinal wave. Propagation of energy: progressive wave, a stationary wave, a standing dimension. 1D wave on a strings, 2D surface wave or ripples on wave. 3D sound and light wave. If particle vibrates in a perpendicular directions to the wave motion, then it's called transverse wave. In strings, mechanical waves are always transverse. In gases and liquids, mechanical waves are always longitudinal because fluids cannot sustain shears. Partially transverse waves are possible on liquid surface because surface tensions provide some rigidity on a liquid surface. These waves are called as ripples as they are combinations of transverse and longitudinal. In solid, mechanical waves may be sound can be either transverse or longitudinal depending on the mode of excitations. In longitudinal wave motion, oscillatory motions of the medium particles produce regions of compressions, high pressure, and rare fractions, low pressure. Plane progressive waves. Wave equations: y is equal to a sin omega t minus kx, where k is equal to 2 pi upon lambda. Wave propagation constant. Wave is moving along x-axis and particle is moving along y-axis. If coefficient of x and t are of opposite sign, then wave move in positive x directions. For example, y is equal to a sin omega t minus kx. Wave is moving in plus x directions and particles is moving in y directions. Similarly, for example, z is equal to a sin omega t minus ky. Here wave motions in plus y directions and particles move in z directions. Differential equations: del square y upon del x square is equal to 1 upon v square del square y upon del t square. Wave velocity, phase velocity: v omega is equal to del x upon del t is equal to omega upon k. Omega t minus kx is equal to constant, then is equal to dx upon dt. Del x upon del t is equal to omega upon k. particle velocity Vp is equal to del y upon del t is equal to a omega cos in bracket omega t minus kx. Vp is equal to minus v omega into slope is equal to minus v omega in bracket del y upon del x. Particle accelerations ap is equal to del square y upon del t square is equal to minus omega square a sin omega t minus kx is equal to minus omega square y. For particle 1, Vp decrease and Ap decrease. For particle 2, Vp increase, Ap decrease. For particle 3, Vp increase and Ap increase. For particle 4, Vp decrease and Ap increase. Relation between phase difference, path difference and time difference 0 pi upon 2 pi del phi upon 2 pi is equal to del lambda upon lambda is equal to del t upon t.